Hello students, now today we are starting with another chapter, that is polymers. As you know, in various fields of life we are using certain compounds which are to be considered as polymers. Like if you talk about a common example, polythene. You say polythene, it is a kind of polymer. You say melamine, which is normally used in crockery, you say it is also a polymer. You say rubber, it is also an example of polymer. So many, you say nylon, it is also an example of polymer. You say polyester, this is also an example of polymer. So there are so many examples of polymers which we come across in our day-to-day life. So now the today's topic we are starting with the chapter polymers. What does this term means? Every term has a definite meaning. So here if you divide, this is polymer, and what do we find? In this polymer, it consists of two parts. There is one which is called poly, other is called mer. Poly means many and mer means units. So how do we define? Polymers are to be called, and secondly, before going to tell you the definition, these are having high molecular masses. So that's why how do we define these polymers? We call them polymers are macromolecules. Means these are big sized molecules with high molecular masses. So polymers are macromolecules which are made up of large number of units which are repeating units. Means which are repeated again and again. Let us take a common example of, say, starch. What do we find? Starch is a good common example of polymer. You heard starch, and this is a polymer of C6H10O5, and we write whole N. This N stands for large number of this is a monomer derived from glucose. So what do we say? Starch is made up of large number of glucose units. So polymer, a macromolecule made up of large number of repeating units. These are polymers. And when I say these are macromolecules, so just see the range of their molecular masses. It comes from 10 to the power 3 to 10 to the power 7 units. Means approximately their molecular mass ranges from 1000 units to 10 lakhs units. See how high the molecular masses these are. So now, but one thing, it's okay, polymer are to be considered as macromolecules, but still there is a difference between the two terms. Macromolecules, fine, with the molecules which have large molecular masses, which are large size. Let us take an example. Let us take an example of chlorophyll. We all know it is an important part of leaves in plants. You see, its molecular formula is C55H72O5N4Mg. Now again it is a macromolecule because it has very large molecular mass, but this is a macromolecule, large molecular mass, but you will not consider it as a polymer because this chlorophyll doesn't have any repeating unit. This glucose is also a macromolecule, but it has a repeating unit as well. So what I mean to say, now it's very clear from this, it is very clear, macromolecule is to be considered as a broader term. Why? Because it includes starch in it, it includes chlorophyll in it. Then what is the difference? It doesn't have any repeating unit and it has a repeating unit. The polymer is a branch, you can say, from the macromolecules only. So remember, there is a difference between the polymer and macromolecule. Macromolecule are all those molecules which are large molecular sizes, large molecular masses, but they may have or may not have repeating units. And polymers, they are also macromolecules. They are also having large molecular masses, large molecular sizes, but they should have some repeating units. So this is important about polymer and macromolecules. Now what we have to discuss here further? Now we are proceeding with the chapter, and in this, first of all, we have to discuss about the types of polymers. We have different type of polymers. These polymers are classified differently on the basis, or I must say on different basis. Like first of all, these polymers are classified into different classes on the basis of their sources. Their sources means, first of all, these polymers are classified from where they are derived. Like for example, these polymers on the basis of their sources, some are termed as natural polymers. Now as the name tells, it's very clear to all of you, natural polymer means which are obtained from the nature. Example, good, I just told you, very good reply, starch. Very good, cellulose is also a kind of such natural polymer which you get from the nature. Rubber is also an example of natural polymer. We get it from the nature. We have then synthetic polymer. Now as the name tells, synthetic means these are to be synthesized. They are also considered as man-made polymers. And for example, we have polythene, very commonly used. I am sure you must be aware about this term also. PVC pipes you heard. Actually it is polyvinyl chloride. We will discuss it later. We have nylon. This is also an example of synthetic polymer. Nylon, you find its various uses. And other class of this on the basis of their sources, we have semi-synthetic polymer. Now semi-synthetic polymer means these are the polymers which are natural in origin, which are obtained from the nature, but by certain chemical changes their properties are improved. They are converted into a better polymer. Like for example, I tell this is rubber, this is natural rubber which we get from the nature. But now when this rubber is vulcanized means, in short I just want to tell you, this natural rubber is heated with sulfur just to improve its properties. So when this rubber is heated with sulfur, you get vulcanized rubber. Now this vulcanized rubber is to be considered as, is to be known as the semi-synthetic rubber. So this is the way. And one more example I just want to share with you. Rayon, you studied about this, I think, rayon. And where you find this rayon? You find it in, it is being used in curtains. It is being used in carpets. This is rayon fiber. And it is also an example of semi-synthetic. You know the name, chemical name? Its chemical name is cellulose diacetate. Cellulose trinitrite is also very good to use, and here it is being used as explosives. So this is on the basis of their sources they have been classified. I told you on different bases they have been classified. Here they have been classified on the basis of their sources. Similarly, they can also be classified on the basis of their structure. When I say on the basis of their structure, on the basis of structure they had been classified. Now how these polymers are classified on the basis of their structure? Like first of all, we have linear polymers. It's very clear, linear. What does it mean? I told you polymer. So many molecules are connecting. So definitely bhai, they will form their chains also na. So means when you say linear, large number of polymer chains running parallel to each other. This is linear polymer. And as the structure you come to know, they are very closely packed. So that's why these linear polymers, they have high density. They have high tensile strength. Very good polymer. They have high density, they have high tensile strength, and they have high melting points as well. This is because of their structure. Second, we have branched chain polymer. Now as the name tells, branched chain, it's very clear. We have polymer chains, but they have branches. They are not very closely packed. They have branches, and when they have branches, these are branched chain polymers. They have branches, they are less closely packed, so they have low melting point, low tensile strength, low density as well. Example I just want to share. When anybody asks, give an example of linear polymer. I just forgot it. You can say an example is high density polythene. If anybody asks what is an example of branch chain polymer, you can say this is low density polythene. In coming videos we are going to discuss these also. And one more thing is there. This is next. This is to be called as the cross-linked polymers. Now when you say cross-linked, now as the name tells, we have many polymer chain running parallel to each other, and they develop certain cross links in between. Cross-linked polymers, and these cross-linked polymers, they are very hard, rigid and brittle as well. Brittle means when they are hammered, they break into pieces. So these are on the basis of their structure. This is the way how these polymers are classified on the basis of their structure. One more thing to discuss today. First, we classified on the basis of their sources. Second, on the basis of their structure. Now next, short, we have to classify them on the basis of intermolecular forces between them. Intermolecular forces. What intermolecular forces do we observe between them? So on this account, these polymers on the basis of intermolecular forces are classified into 4 types. First of all, we have an example of elastomers. Now I think it's very clear. The name tells elastomer. Elast means these are the polymers have property of elasticity. I hope you all know the meaning of elasticity. Elasticity is a property that when you stretch, when you pull, the article get stressed, and when you remove the force, then the article get its original shape. Elastomer, elasticity. Pull, they get stressed. Remove the pull, they get their original shape. Now point is there, why do we observe in this in elastomers? So actually we find that in case of elastomers, they have long coil chains with weak intermolecular forces in between them. Coiled structures. So weak intermolecular forces, van der Waals forces between them, but interesting, they have few cross links in between. So in these elastomers, what do we find? Because they have coiled structure, what do we find? When we apply a pull on both the ends, they get straightened and they get stressed. But natural, when they have coiled structure and you pull them, so they got straightened and they get stressed. They elongates in their length because of weak van der Waals forces. But as and when you remove that pull, what forces come into action? These forces. These are cross links, which are few cross links, but they come into action and they bring back these polymer chains to their original shape. You apply pull, they get stressed. You remove the pull, cross links bring them to their original state. These are elastomers. They have elasticity on the basis of intermolecular forces. Now when you talked about elasticity, now what next? They have elasticity, less tensile strength, and remember, elastomers, they have weakest intermolecular forces between them. You observed right now, weakest intermolecular forces, you see, they are having van der Waals forces or few cross links only. Now second, we have fibers, just opposite to the elastomers. Just opposite to the elastomers, we have fibers. When I say fibers, so what is the meaning of these fibers? Fibers, they have strongest forces in the polymers. When anybody asks, name what are the polymers with the strongest intermolecular force? These are fibers, strongest intermolecular forces. And interesting, what do they develop? Why they are to be called as the strongest intermolecular forces? I think you can remember from last year chapters, that is chemical bonding. I think you can remember, there you discuss about dipole forces, you discuss about hydrogen bonding. So in these fibers, we observe between the polymer chains, we find hydrogen bonds, and between the polymer chains we find dipole-dipole interactions as well. We will discuss the examples later. I just want to tell you one thing. When you will discuss about the nylons, here you will find hydrogen bonding as an intermolecular force between them. Fibers, nylon fibers, how they are bonded, how the polymer chains are bonded, they are bonded by hydrogen bonding. And I want to definitely utilize the time. If you talk about polyester fiber, this is also called as terylene. This is also a very common word. It is also called as dacron. Terylene. Remember, when you purchase some kind of cloth, you purchase it by the name of terrycot, terylene. That is a synthetic fiber which is used to make fabric. So this is terylene. Here in these polymer chains we find dipole-dipole interaction. So here in case of nylon we find hydrogen bonding, and in case of polyester we find dipole-dipole interactions. And third, we have the case of thermoplastics. And remember bachcho, these thermoplastics have intermolecular forces intermediate to those of elastomers and fibers. Where we find the weakest intermolecular forces, come on? Yes, in elastomers. And where we find the strongest intermolecular forces? Correct, in fibers. And remember, here we have weak van der Waals forces, here we have hydrogen bonding, dipole-dipole, but in thermoplastic we find the forces in between the two. What is the property of thermoplastic? Thermoplastic has a special feature that at number of times when they are heated, they become softened and they can be molded into any desired shape. So when thermoplastic has a special feature, when they are heated, they get melted, and when they are cooled, they again become hardened repeatedly. Like in a polythene is the best example. This can be number of times, it can be heated and it can be remolded again. Many more examples are there, we will come to know later on, but this is thermoplastic. This is an important characteristic regarding thermoplastic. And in continuation to this thermoplastic, we have another, this is called thermosetting plastics or thermosetting polymers. So in these thermosetting polymers we find it is a kind of polymer which is when heated undergo a chemical change, a change in chemical composition, and then it can be molded into any desired shape. But when it is heated, it can't be softened and it can't be reused, it can't be remolded. And best example is bakelite. Bakelite, you know it well. Bakelite is a very common polymer. Electric switches are made up of this bakelite. Comb we use, it is also made up of bakelite. So this is bakelite. It is an example of thermosetting polymer. When bakelite is to be formed during chemical combination, during when it is heated, the composition of bakelite is heated, then what do you find? You get, it is, I just want to tell you here, it is phenol formaldehyde polymer. So when phenol and formaldehyde are heated together, they undergo a permanent chemical change, and then they can't be softened on further heating, they can't be remolded again. Reason? Because they develop a certain kind of crosslinks in between. So these are the classification of polymers on the basis of intermolecular forces. So on 3 account we have classified the polymers, but still few more bases on which polymers can be classified. You will come to know in your further videos. Please watch and subscribe, and number is scrolling on your screen. Any problem, any doubt, you can share with us. Thank you.